Good day, everyone. So, the first thing that we need to be able to do is to understand what is really vertical projectile motion. We all understand that vertical, it means the upright, right? And then projectile, we need to have a proper definition of what is a projectile. And we know that a projectile is basically an object that is moving through the air, experiencing free fall after being dropped, thrown, or shot at. And motion basically means movement. Okay, so what is projectile? I was trying to explain on top. Mostly, I'm just reading through the topic. So, projectile motion. It's projectile motion. Basically, projectile is an object that is given in while while there is only one force that is acting on it, which is the gravitational force. Once launched, the only force acting on it is the force due to gravity in the absence of air resistance. The object is free falling with a constant acceleration, which is 9.8 meters per second, which is gravitational acceleration. And we all know the direction of gravitational acceleration to be going downwards when it is positive because of the gravitational force, right? Okay. And yeah, just like how I was saying that the direction of gravitational force is always downwards. Okay, there are few facts concerning vertical projectile motions which are important that we need to pay attention to. So we're gonna go through these key concepts that we just need to understand pertaining vertical projectile motion, which are two cases: the throwing of an object upwards. We need to understand that when we throw an object upwards at the highest height of the upward motion, the final velocity is zero, due to the fact that when an object is projected or thrown upwards, right, it will be opposing the motion of gravitational force. While opposing the motion of gravitational force, it decreases in speed or acceleration velocity, basically. And when it reaches the final velocity, the velocity is equals to zero. And when it drops down, the final velocity, yeah, when it's on the ground, when it is reaching the ground, it's high due to the fact that it will be accelerating, going downwards on the going towards the gravitational force. And the time between v initial and v final is the same for the ball thrown, and also the ball is now falling from the final velocity going to the v max. Okay, and the second scenario is when the object is dropped or released from rest, and this is usually known as free fall. And free fall is understood as the unhindered movement of an object in the gravitational field of the earth when only the gravitational force is acting on it. So this is free fall, and we illustrate it with a diagram. When an object, right, is at rest, here is at rest, that's our v initial, which is different from the v initial of being thrown or being projected. This one is just falling, right, from a certain point which is high above, just like a person when you when you drop your phone, when you're holding it, it will be at 0. There's no effort that has been done, it just fell by mistake. So the initial velocity will be 0, and the max, the final velocity when it reaches the ground, we need to calculate it, or we are given. So these are the two different cases that we see when an object is at rest and it falls down. But there's also another concept that we're also going to talk about, which is when there is an object within an object that is moving, going upwards, either be it an air balloon, either be it a flight. It differs. But when something falls from an object that is already in motion, the final, the initial velocity of that object that is moving, we take it into consideration as the initial velocity of the object that will be falling down. But you're going to go through different types of questions that will be having all those different scenarios. But I just wanted us to know the facts pertaining vertical projectile motion. And then when it comes to us solving the problems of vertical projectile motions, then using the equations of motions, there are certain key concepts that we need to understand. There are certain guidelines that we can use, and they will help us uh, reduce errors. It will also help us when it comes to the struggling that we have in solving the vertical projectile motion questions. So the first thing that you need to do, you need to draw the diagram and illustrate the situation that you have been given on the question, and then enter all the numerical values on the diagram. When you enter all the things that you are given on the diagram, it will help you to choose the equation that you're going to use, because you'll be knowing the quantities that are known and the quantities that are unknown when it comes to the equation that you're going to use. And also the first thing that you need to do, the second thing that you need to do before choosing your equation, illustrate, of highlight your direction. If your direction is positive, make sure that upwards is going positive. Do not change the sign of the direction. Whenever you have chosen your direction, that direction should go through all the way. Also, when you're now going to draw the graph, because when you highlight a graph that is opposite from what you were calculating, it can become an error as well. So we need to take into consideration that when we are now, after we have identified our equation, we now substitute the known values that we have so that we are able to solve for the unknown values. Okay, so which are the equations that we have pertaining equation of motion? There are 4 equations that we use. Prior to us getting our answer, we should give the direction by words after we finish calculating the vector quantities. So these are our equations of motions that we have, and there are 4 of them that we usually utilize in vertical projectile motion. But as for me, I love to use these 1, 2, 3 equations when I'm answering most of the questions. But I know there are some, for my reasons, because it can become, it's an it's an it's an it's an equation that we can all utilize. And we know that A stands for acceleration, which is meters per second, and which is our gravitational force, right? And also delta x, it is the displacement, the change in position. And some people confuse delta x with distance. distance and displacement, they are two different things altogether, and we know that, right? Okay, and delta t is the change in time, and vi is our initial velocity, vf is our final velocity. Now we are going to go to an example, one example of a free fall, a free falling object that is going downwards, right? So dropping an object vertically downwards, which is the free fall motion. Okay, a boy is on top of a tall building and drops an orange which is going down in free fall. The ball is 40 meters high. Calculate the velocity of the orange reaching the ground. The second question says, calculate the time taken for the orange to reach the ground. So how do we tackle this question? We know that we are supposed to first draw the scenario, the situation that we have been given, and we know that we know that we're going to choose our direction, and we have chosen upwards as positive, and this should also tally with what will be in our solutions, right? The ball is the boy is on top of the building and dropped an orange which is going in free fall. So here already we have been told that it's free fall, and we know that when an object is free falling, it's starting from zero, it's at rest, and already there we go, we highlighted there. And then we've been given our displacement, our delta x, which is 40 meters high, and there is our 40 meters high, and we need the final velocity, since the question says the velocity of the orange upon reaching the ground. So meaning we need to have our VF. So what do we have? We have our V initial. We know our gravitational force, which is already given, which is 9.8 per meters per second. And we have our delta T, our delta X. So what do we have what don't we have? The unknown quantities that are missing. We don't have delta T and we don't have final velocity. So which equation of motion are we going to choose from? Since we don't have VF and we don't have delta T. So this is the equation of motion that is proper to use the T. And we have to make sure that on the answer, on the solution that we get, we have to show the direction in words like what we have stated there. So the second question says, calculate the time ground, reach the ground. As we can see, we now have only one unknown on our question. So which equation will be proper for us to use? Now we are going to use the equation that has VF, V initial, and delta T, because we just want to find delta 2. So we substitute our values and then we solve for T. We make T the subject of the formula, right? We make T the subject of the formula. That's the end.